Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
And I'm Luke. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, Luke, where do you attend school and what grade are you in?
Highgate Elementary, and I'm in 5th grade.
I was going to guess Highgate because of the shirt right there, and I do like that shirt. I commented on that. It's a smart-looking shirt right there.
Thank you.
So, how is 5th grade?
It's good.
What's so good about it?
Well, I like the math more than 4th grade. We do harder, and I like challenging math.
Oh, good. So, what kind of things have you been doing so far in 5th grade that you like that are a little bit more challenging than 4th grade?
Long division, longer multiplication,
Okay.
and like volume and stuff like that.
Good. So, volume's what you're working on now, right?
Mm-hmm.
Have you done a lot of work with fractions?
Yes, we have.
What about decimals?
Yes.
And what about percents?
Not yet.
Oh, good. So maybe we'll do a little percent work today. So you already have fractions and decimals. So all three of those go together, fractions, decimals, and percents.
Mm-hmm.
And I know you brought in some volume work, and we'll do some of that, but maybe we'll hit a little percent also later. You good with that?
Yeah.
All right. Before we do any of that, you have to help me out with our problem of the day. Can you help me with that?
Mm-hmm.
All right. Let's take a look at it right now. This is the problem of the day. This is put out on all of our social media, and it says 5x plus 8 equals 3x plus 22. Do you have any idea what any of that means? Or how to start it? Any thoughts at all on it? Because I know you just said you like challenging math problems, right?
Mm-hmm.
I bet you haven't done this in 5th grade yet, have you?
No.
Well, guess what? I'm going to get you ready for 6th grade right now. So here we go. All right, so just taking a look at that. What are you thinking about, or what is giving you a problem right now that you're looking at it?
Maybe we could do 5 times 8.
Okay. And why would you think that?
Because it says 5 times plus 8.
Okay, so the x, and that's a good thing that you brought that up, right? Because a lot of people associate that x with multiplication, and rightly so. But when you have the number and the letter together, one is a coefficient, one is a variable. So the letter is a variable because it can vary what the value of it is. So it could be n, it could be 5n, 5x, 5y, 5b, it could be 5 any letter, and it's going to mean the same thing. Now, do you know what it means when a number is next to another letter or another number next to another number in parentheses? Have you ever seen that before?
Yes.
Do you know what that means?
Not very much.
Okay, it means multiplication. So you're on the right track.
Yeah.
So it means 5 times something plus 8 is equal to, now what do you think 3x means?
3 times, well, not times. Like
Yeah, 3 times
3
something,
times
right?
something, yes.
Because when you have those two together, it means you're going to multiply. All right? Now, we don't know what x is yet, do we?
No, we
So
don't.
we're trying to find that out. Okay, so this is trying to solve for x, and you're going to do this hopefully in your regular 6th grade classroom next year. But when you get to 7th grade, guess what? You're going to do hundreds of them. And guess what you're going to do when you get to 8th grade?
Thousands.
Thousands of. Yeah, see, you're a bright boy, right? You already got it, right? So if you kind of get this right now, it's going to just be a little head start for you when you get to it, okay?
Yeah.
So the first thing we want to do is we want to get all of the x's, anything with an x on one side of the equation,
Okay.
and any numbers that are just numbers by themselves on the other side of the equation. So it's like a balance beam.
Okay.
And think of the equal sign as the point in the middle, the fulcrum. Okay? So, which of the x's is smaller, 5x or 3x?
3x.
3x. So we agree on that. So we want to get the 3x over on the other side. So we're going to subtract 3x. And we're going to do this all mentally. Okay? We're not going to write anything down. You and I, we're going to do this mentally. So if I take away 3x on the right side, there's no x's left over there.
Yeah.
Okay? But I have to take 3x away on the other side also. So what's
Yes.
5x minus 3x?
2x.
2x. Good. All right. So far I have now 2x plus 8 equals 22. Does that make sense where we're getting all this from?
Yeah.
All right, good. Now that plus 8, we want that over with the 22
Yeah.
because we don't want it with the x's. We want to get them apart. So if I have a plus 8, what's the opposite of plus 8? Like what's the opposite of multiplying?
Subtracting.
Dividing,
Dividing. Yeah.
right? So what's the opposite of addition?
Subtraction.
Okay, so if I have plus 8, what's the opposite?
Subtraction.
Subtraction. So I'm going to subtract 8 on both sides. Now if I take away 8 on both sides, when I have 22 and I take away 8, what's left?
14.
14. So now, do you remember what's on the left side?
2x.
2x, perfect. So I have 2x is equal to 14. Now I don't want 2 x's, I only want one of them. Now if 2 x's, right? Here's an x and here's an x. 2 of these are going to be the same value, and they both equal 14 put together.
Yeah.
What's one of them going to be?
7.
How do you know that?
Because 14 divided by 2 is 7.
Okay, so let's take a look at the problem again. Now we have 2x equals 14,
Yeah.
right? That's where we're at. But we don't want 2x. We only want 1.
1x.
Now when 2 and x are next to each other, they are being, remember they're being multiplied,
Yeah,
right?
multiplied.
Because they're together. So what's the opposite of multiplication?
Division.
And if I want to get 2 and I want to get to 1, I have to go 2 divided by,
2.
perfect. So if I divide one side by 2, I have to divide the other side by 2.
7.
So 14 divided by 2 is 7, see?
Yeah.
So x equals
Equals
7.
7 is the
Now
answer.
let's put it all together. Let's go back up to the original problem. What's 5 times 7?
5 times 7 is 35.
And what's 35 plus 8?
35 plus 8 is 43.
Perfect. Now we have 43 on that side. Let's go to the other side of the equal sign. What's 3 times x, and what is x?
X is times.
Right, and it's 7, right? Because we
Yeah,
know
so
x is 7.
x
So
is
what's
7.
3 times 7?
3 times 7 is 21.
And what's 21 plus 22?
21 plus 22 is 43.
Now doesn't 43 equal 43?
Yes.
Yeah. So we know that the problem is done correctly. Now, you're probably going, okay, yeah, I just did that, and it kind of made sense as I was doing it, but I'm not really sure what I did.
Yeah.
Does it a little bit?
A little bit.
Okay,
Yeah,
that's all I want, a little bit, because I don't expect you to master this doing it in your head the first time you've ever seen it. So we're going to go with x is equal to 7. Do you agree with that?
Yeah.
All right, let's take a look and see if the answer is correct. X is equal to 7. Good job, dude. First one done. All right, so you're well on your way. All right? That wasn't too bad, was it?
No.
Yeah, you're like, come on, old man, you're making me sweat on the first problem right here. I have no idea what's going on. When you do these in 6th grade, hopefully your instructor will kind of go through it where you guys go slow. I'm sure you're going to. And if you don't do it in 6th grade, you're going to do it when you get in 7th and 8th grade. You're going to do hundreds and then thousands of these things. And if that makes sense to you, you're going to go, oh, yeah, that's right. I remember that old man made me do one of these things in my head. I had to do it like that. And then it's going to come back to you, all right? I promise it's going to happen. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Luke is a 5th grade student who's just doing middle school math right there. He's from Highgate Elementary. Now, Highgate is a pretty new school, isn't it?
Yeah, this is our 2nd year.
2nd year. So have you been there both years, or is this your first year?
Both years.
You've been there both years. So how is it different than the school you were at previous?
It's newer. Well,
Do you like this school better than the other one?
yes.
Why? And don't say because it's newer. Because everybody likes new schools.
My dad's the principal.
Oh, check that out, man. That is so sweet. So how often do you have to go to the principal's office?
0 times a day.
0 times a day? You don't just go by?
Bad reasons. No.
Bad reasons. There you go. I was going to say, you can pop in and say hi to your father every once in a while, right? See how everything's going, making sure your student doing his work, right? Because I'm sure he makes sure you're doing your work, right? So you can go, hey, I'm checking, make sure you're doing your work, right? All right, cool. So you like Highgate. It's a pretty nice school.
Yeah.
Are you involved in anything at school other than just being a 5th grade student?
I play the trumpet.
And how's that going?
Good. I like it.
You like it? Is this your first year doing it? Because I think 5th grade is when you can
Fifth
start
grade,
playing
yeah.
instruments.
You can't do it 4th grade, so yeah, this is my first year.
So this is your first year. What made you select trumpet?
Well, the other ones were like, I wanted to start easier, and I thought the trumpet was easier.
Okay.
Like all the other ones seemed really complicated, so I just started off with the trumpet. I can move to a different instrument next year.
Do you think you'll do that?
No, I like the trumpet.
You like the trumpet. You know what I think you ought to do is do the trumpet for 5th grade and 6th grade, and you get pretty good at it, right? And then if you want to, what I suggest is you can try another instrument, because I think once you learn one, it'll be easier to learn another one, and then you get a little more versatile also,
Yeah.
right? So it's not bad to try another one also, but you want to master the trumpet a little bit first, right?
Yeah.
Can you play a lot of songs right now, or are you just kind of in the beginning still?
Beginning still.
Still
like,
beginning?
I'm not the best, but
Do your parents close the doors when you're playing and like, oh, go in there and,
yeah, I just close my own door and play in my room.
you know, do you have a mute for your trumpet yet?
No.
Okay, I remember when Mickey started playing trumpet, we got a mute for him, and he. That's just one way that you can keep practicing where it's not as loud. And then there is a way to use the mute for actual purposes where you want that kind of an effect with the trumpet. All right? All right, time now for today's Math in the News. All right, Math in the News actually has to do something with what is called Math Counts. And Math Counts was an event that took place last week, or not, was it last week or a couple weeks ago, right?
February 3rd?
Well, yeah, it's just March right now, but, so we've got,
Like 3 weeks ago, I think.
let me make sure I've got this going right here. So anyway, Math Counts, because Cindy, you and your school participated in Math Counts.
Yes.
And tell us a little bit about the experiences that your students had with Math Counts.
What kind of experiences do you want to know about?
Well, how long do they train for Math Counts?
Oh,
I know every
gosh.
school's a little different, but
Yeah.
how long do you guys train for this?
So for Warren, we started training early October, and we met once a week and practice, and then practice and practice and practice and narrowed our team down, and then we went to Math Counts, and they did very well.
Right, because I know the students at Warren do very well, and
Yes.
did you guys win the county thing this year? The
Yeah, they did
team?
win the team round.
Okay.
Yes.
And I know that 6th grade students do it also, so I bring a class from one of the 6th grade schools, and they compete as well. And it's a contest where 6th, 7th, and 8th graders all compete together. So maybe next year, when you're in 6th grade, you can ask your instructor, hey, can we do this Math Counts thing? And see what happens, all right?
Especially if you like challenging problems.
Yeah, because those are very challenging problems, because they're aimed at 7th and 8th grade students. 6th grade students do them, but they're also problems that you will do when you're in high school, because they want to see how high you can go and how far you can progress with these problems. But before we get to our Math in the News, because obviously we're having a little bit of difficulty getting that one up right now, we're going to go ahead and have you start working on some volume. Are you ready? All right, let's take a look at one of your first problems. So here's the work papers that you brought in. It said the completed large rectangular prism is made to have 2 layers. Now, how many layers do we have right there?
1.
1. And it said it's made to have 2. What is the volume in cubic centimeters of the large rectangular prism? So you and Cindy talk about this and tell me what you're coming up with. So you can just look at it. If you want to, you can draw something out. It's up to you guys.
So when you say the large rectangular prism, I just want to make sure reading it correctly. We're looking at it as if it did have 2 layers.
Correct.
Correct? Okay.
Yeah.
So what's the volume of the first layer?
the volume of the first layer is 6.
Okay. And so if you
Cubic
added another
centimeters.
layer on top of that,
It would be 12 cubic. It would be 12 cubic centimeters.
yeah, because it would just add a whole
Yeah.
nother 6
Yeah.
cubic centimeters to the top.
So explain to Cindy what you know about cubic centimeters. Why is that called cubic centimeters instead of just 1 centimeter?
Because length, width, and height makes like cubic.
Right,
It's
because you have 3 dimensions now, right?
3 dimensions.
Yeah, because you're looking at the cube itself and how many
Yeah.
little cubes make up that layer, right?
Yeah.
And so it's labeled as cubed. And then just a centimeter is just like how long one side of it is.
Yeah.
Or like one edge of it.
All right, let's take a look at the next problem you've got. So there we've got the 2 layers, and let's take a look at some of the problems that you've got. So how many vertical layers make up the prism? So remember, you've got your 1 layer, and then you've got the other layer on
Yeah.
top.
So vertical layers,
You wanna take a look at it again?
Height. Okay. 2.
I'm just thinking because vertical is like this. So do they mean how many layers are this way? Or do they mean stacked?
Stacked.
Vertically. Okay, stacked vertically. So how many
2
layers are there?
2 layers are stacked vertically.
Are you sure about that?
Yeah.
Because at first it sounded like you were like 2.
Yes, I'm sure about that.
Good, that's what I want. I want confidence in your answer, right? Don't go, "Oh, I don't know if it's 2 or not, or I think it's 2, right? If you know it's 2, say it's 2. All right, so what's the volume of each layer?
The volume of each layer it's 6.
Yeah, that's
Just
kind of
like the
what we
other
did
one.
in the beginning, huh?
Right. And then what is the volume of the rectangular prism?
Is that the whole thing?
12.
So it's pretty easy so far, right?
Uh-huh.
Good, I'm glad everything is nice and easy for you, because when I give you the one that I'm gonna give you in a minute, we'll get you going here. All right, so here we go. Let's take a look at this one. So it says the bottom layer is 3 inches across, 3 inches wide, and 1 inch tall. So it's a 3 by 3 by 1. So, what is 1 layer in cubic inches?
9. 9 cubic inches.
How'd you get that?
3 by 3 by 1. 3 times 3 is 9. Times 1 is 9 still, so 9 cubic inches.
All right, so explain to Cindy how you're going to do part B and part C.
We could just add 2 layers of 9
Okay.
and 3 layers of 9 for C, and we would get our answer.
So you just said 3 layers of 9,
Yeah.
or 3 layers of 3?
3 layers of 9 cubic inches.
And what would that be?
27 cubic inches.
All right, keep going, you're not through yet.
And then for C, it
For
says 4
C,
layers,
4
right?
layers.
So how many layers of 9
is-
do you need?
36. Well, we need 4 layers,
Mm-hmm.
and 4 times 9 is 36. So it's 36 cubic inches.
Excellent, let's move on to the next one. So you're tearing through this little work
Ooh,
packet
look at
you've
that
got
one.
here. All right, Violet must finish stacking cubes to create a solid rectangular prism, because as you can see, there's kind of spots and holes in it right now,
Yeah.
right?
It's not complete.
The completed prism will be 3 centimeters high, 4 centimeters wide, and 2 centimeters long. So, we want to know how many cubic centimeters it will be when it is completed. So,
Okay.
So
explain to Cindy what you want to do with this.
So the width is 2, the length is 4, and the height is 3. We could do 2. It's 2 by 4 by 3, or 3 by 4 by 2. 3 times 4 is 12, times 2 is 24. So it's 24 cubic centimeters.
Okay. Now you said 3 by 4 by 2. Can I do 2 by 4 by 3?
Will it come out the same?
Yeah.
What about 3 by 2 by 4?
Yes.
You positive?
Uh-huh.
You telling me that no matter what way I multiply those, it's always going to come out the same?
Yes.
All right, that's cool. I just want to make sure. See, you want to be sure, right? If you go, yeah, I'm confident in that, then be confident in that, right? If somebody questions it and you know that it is correct, you don't have to rethink it, right? Go, yeah, it is, right? And then explain. How can you explain? Because I don't believe that 3 times 4 times 2 is the same as 2 by 3 by 4. Can you explain that to me, why it's the same no matter what order I put them in?
2 times 3 by 4 is, so 2 times 3 is 6, by 4 is 24, and 2 by 4 by 3, 2 times 4 is 8, times 3 is 24. So they come out to the same answer.
Do you think there's any kind of mathematical rule or law or property that there is to go with that? Ask Cindy, see if she knows one.
Commutative property.
Commutative property?
Do you know what that means?
Like it's all the same numbers, so it's not going to come out to a different answer.
Well, that's a good way of explaining it. So
Yeah,
ask
so
Cindy
if you
what commutative property means.
If you multiply 2 numbers, you can reverse the order of those 2 numbers and multiply them, and you'll still get the same answer. Does it work for adding? If you add 2 numbers, you can switch the order and still get the same answer?
Yeah.
What about subtracting?
Subtracting?
If you did like 5 minus 2,
No.
would that be the same as 2 minus 5?
You can't do 2. Well, yeah, you can't do 2 minus 5.
Yeah, it wouldn't work, right?
It wouldn't work.
Oh, here we go, hot shot. Let's jump to the back a
Division
little bit.
2.
All right. So these are 1-inch cubes. Got it? All right, so we're going to take a look at it. So we've got a 4 by 4 by 3. Now you have to figure out what goes in each of these spots. So each cube has a volume of how many cubic inches?
Each cube has a volume of
Do you mean the whole cube? Or like one little cube?
One little cube,
Okay.
right?
1
Because
by
what
1
does the
by
4
1.
by 4 by 3 mean, first of all?
4 by 4. It means it has a width of 3. No, it has a width,
You can call that a width of 3, that's fine.
length of 4 and a height of 4.
Okay. So how do you think they got those? Like what would each little cube be?
1 cubic inch. 1 cubic inch, and there's 3 cubic inches in the width, 4 cubic inches in the length, and 4 cubic inches in the height.
So for this part A, what do you think you're going to put in that spot? Each cube, and they're talking about each little one.
1 cubic inch.
Okay. So what about each layer?
12 cubes. It's made up of 12 cubes.
How many layers are there? Let's go back to it.
4.
Okay. And then the final one, the volume of the whole prism. So let's bring back the whole prism again.
48.
How do you get 48? That was pretty quick.
3 times 4 is 12 times, so 4 times 12 is 48.
You got that pretty quick. You sure Cindy didn't tell you while I was moving the paper?
No, I'm sure.
So you said 4 times 3 is 12, and 12 times 4 is 48.
Yeah,
What if I went 4 times 4 times 3? What would that be?
the same thing, because 4 times 4 times 3,
So what's 4 times 4?
16. 16 times 3 is 48.
Are you sure? Because it looked like you're kind of questioning yourself there.
Yeah, I'm sure.
You sure?
Yes.
Okay. So if I can take numbers and rearrange them like that and multiply them and they still come out to 48, what property is that again? Do you remember what that is?
Commutative.
Commutative property, right? So you feeling pretty good? You feel pretty comfortable with that? Because a lot of the students in your classroom are probably going to go, yeah, we like doing volume because we just have to multiply 3 numbers together like that, right? But you know a little more about volume now, right?
Yeah.
Because you can commute those numbers around, move them around, and you now know a little bit more about the commutative property, correct?
Yes.
All right. How you feeling? Pretty good?
Good. Yeah.
Very good. Well, you know what? The bonus problem that I've got for you set on volume, we're going to do right after this.
When it comes to water in California, there's no more important single region than the Sacramento-San Joaquin Delta. The Delta is a major hub for fresh water in California. It covers more than 1,000 square miles and supplies water for about 25 million people. The Delta is formed by the confluence of the Sacramento and San Joaquin rivers. When wild long ago, the region was rich with wildlife and wetlands. In the 1800s, levees were built that converted the landscape for agriculture, resulting in one of the country's most productive farming regions. Now, more than 1,000 miles of levees traverse the Delta. Twice each day, the tides push salt water west to east through the Golden Gate into the Delta. Fresh water enters the Delta and then typically flows from east to west, moving through the levee channels to San Pablo Bay, San Francisco Bay, and eventually the Pacific Ocean. When needed, a large portion of the fresh water entering the Delta is diverted from the Sacramento River at an engineered water gateway called the Delta Cross Channel. Once diverted, the water moves south through leveed canals toward the pumps where it is pumped into the California Aqueduct and the Delta Mendota Canal for use in agriculture and for use by people in Central and Southern California. Challenges such as increasing demands on the available water for agriculture, urban, and ecological needs, along with an aging levee infrastructure, subsided islands, decreased water quality, saltwater intrusion into the Delta, and a changing climate combine to create a complex system where there are no simple solutions. Integrating research and monitoring into the management of the Bay Delta ecosystem provides a framework for using the best available science to cope with risks and uncertainty. USGS scientists in a wide variety of scientific disciplines seek to understand how the Bay Delta works, to monitor changes in water flow and quality, as well as ecosystem functions over time, and to provide information and decision support tools for the management of California's water system. Through the work of these scientists, USGS contributes essential scientific support to managers and policymakers striving to address California's water challenges and support a vibrant Bay Delta ecosystem, community, and economy. Earthquakes, land subsidence, and flooding pose significant threats to California's fresh water. Aqueducts, pipes, and sewer lines can break, and levees can breach. In the Sacramento-San Joaquin Delta, at the heart of the state's freshwater system, the huge areas of farmland between leveed channels could suddenly be underwater. And water to more than 25 million people could be crippled or cut off entirely. Impacts would affect everything from families to farmers to fish, and be felt well beyond California. Delta farms are subsiding because they sit atop ancient marshlands, which break down over time. As the land subsides, the levees are weakened. Over 1,000 miles of levees in the Delta are at risk of failure. Compounding the problem, a few earthquake faults pass through the Delta, while much larger faults run just beyond that. In wet years, flooding from severe winter storms can overtop levees, or cause weakened levees to breach. If the levees failed, salt water from the bay could be rapidly drawn into the Delta and potentially reach the water system pumps. This could contaminate much of the state's fresh water supply and destroy livelihoods and local commerce, where Delta farms would be flooded with salt water. These are complex problems in need of attention and solutions.
Time to get to work.
USGS scientists are working to better understand the vulnerability of the Delta's levees to various hazards. They're monitoring ground motion from all nearby faults, and they're building three-dimensional models of the geologic subsurface to better predict how strong ground motion will spread following a major earthquake. They're defining historic flood patterns to help managers identify which levees to reinforce or where to stage materials for possible breaches. Teams of USGS scientists monitor hydrologic flows and coordinate with water operators, who would work to keep saltwater out of the pumps after an earthquake, levee break, or other event. This is critical information that local governments and emergency response teams can use for planning, making us better prepared to respond to catastrophic levee failure. Want to know more about hazards facing the Delta's water system? Why not start with science?
We'll be good to go.
Always information need to know about the deltas for a healthy water system in California. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school years. Phone numbers are at the bottom of your screen periodically throughout the program. Today, our tools of mathematics. Usually we have something that we record someplace and then we are able to show you guys that later on. Today, I was fortunate enough to have the real deal come in. We've got some architects with us from Ordiz-Melby. So Manuel and Jeannie, thank you for coming in, both of you.
Thank you for having us.
So briefly, kind of, what does an architect do?
I'll let you take that.
We often get this question asked a lot, and what we do is design buildings. We don't build them, we design them.
So you design them. So you come up with the creative ideas. Sometimes a client will say, I need this, this, and this, and then those are the parameters, and you come up with something that will satisfy their need.
Correct.
Now, how long, or what do you have to do in order to become an architect? Because there are some kids going, hey, I'd like to be an architect if I'm using creativity, and I know I need to use a little bit of math, but what do I need to do to become an architect?
Math is definitely a good skill to have. There's also communication, because we're constantly presenting our designs to our clients, so good communication is a good skill to have. But after high school, go on to college, get a 5-year accredited architectural degree, and then you begin working under a licensed architect. And we have to work under a licensed architect for a number of years. It might be 5 years or 8 years, depending on your degree. And then you get to start taking exams.
Oh, to make sure you know what you're doing.
Yeah, so there's 6 exams, and then there's one big California exam. So basically right now, 7 exams, and then you can call yourself a licensed architect.
So it's kind of like becoming a lawyer, where you take the bar at the end of the whole thing to go, all right, do you really know what you're doing? And then here's this big
Yes.
one, bam, now you can go and...
Yep.
and
Exactly.
now, they don't say you practice architecture, right? Like they say you practice law.
No, we do.
We do.
Oh, you do?
practice
Okay, so you
architecture,
practice
yes.
architecture.
Yes.
But you guys are pretty good at it though, right?
With
We're
a lot of
practicing
practice.
every day. Yeah. We learn something
of
every
practice.
day, so
Oh,
that's why
good.
we
Well,
repeat
that's
that.
probably one of the best things about it. You know,
Yeah.
whatever you do is constantly being able to learn something. Are there different types of architects?
Yes. In our instance, we are mainly educational architects. There are commercial architects, institutional architects. And the difference are education, schools, libraries, that kind of thing. Commercial architects, stores, grocery stores. and
Airports, you might have an
Airports.
architect that specializes in airports.
Okay.
We could not do an airport. We don't have that experience. There's codes and things that are involved in each
Gotcha,
different
gotcha.
type of building. There's architects that just do houses, residential. We don't do residential.
And I know you guys because I know Bill and Danny for a long time, and they've built a lot of the schools in Kern County.
Correct.
And now you guys are kind of heading everything up, and you guys are going to talk to us about the tools of mathematics. All right. So so here I see that you've got a couple of floor plans. Now, why do you have 2 different floor plans, but they're the same thing? Can you explain that a little bit?
Yeah, so we, if you tried to draw a building just to full scale on a piece of paper, you would need a piece of paper as large as the building. But we can't do our drawings that way. So to get them to fit on these size, could be bigger drawings, but to get buildings to fit on the paper, you have to scale it down.
Okay.
And so that's where we use scale. This, as you can see, they're both the same. They're same building, but this one is drawn at 3/32 of an inch equals 1 foot, and this one is drawn at 1/16 of an inch equals a foot. So depending on what kind of media you're putting it on will determine scale. Maps, for instance, road maps, you can't, you would have a
Right,
really
but-
big, but they scale it down. So it's like 1 inch equals 10 miles or something.
Okay. And is there a standard scale that you present people things with? Or is it just they go, this is what I need, or you just go, hey, based on what you have, this is the proper scale to show you what we're doing?
They're typical scales, 1/4 inch and 1/8 of an inch scales are the typical ones that we try to do everything at. And it just depends on what we're trying to present and who we're trying to, how much detail we want to see is really where it comes down to.
My uncle, and being an old man myself, he was old also when he was doing this, but this is back in the 60s, and he was an architect, and it didn't look like this because a lot of things were hand-drawn.
Yep.
Exactly.
Okay, and then my cousin, also an architect, and his now look like this because
Yes.
he's currently doing it. So are these things that you start hand drawing first, or you automatically now are able to do these things on the computer?
We actually do start with hand drawing sketches. We
Okay.
use, this is called flimsy. You can see right through it. So we lay over and we take a pen, and if I'm trying to decide whether this staircase wants to be in that corner or it wants to be over here, I can start designing it. And we use the flimsy to do that. And then we pass on sketches, and pretty much at that point it goes into the computer and it stays in the computer all the way through construction.
Oh, good, okay. So I see that you've got a lot of tools, and that's why you're here, to talk about the tools of mathematics. So this is something I know that a lot of students see and they go, well, is that a rule? Okay, but I'm sure it is on one of these sides, right? But explain a little bit about what you've got and how that's different than what a student might see that they have in their desk all the time
Right.
as a rule.
This is a 6-sided rule, scale is what we call it, and it has 11 different scales on it. So this allows us to carry a lot of different scales in one tool. So on each side you have a 1/4 inch and you have an 1/8 inch, or you have 3/4 or 3/8, and we can use that depending on the size of the drawing and do what we need to do and sketch out what we need to sketch out without having to carry different scales.
Right, I was going to say, because otherwise you'd have quite a few of them if you've
Exactly.
got so many on one.
Exactly.
So are these just different versions of the same scale that you've got, or are there different scales on these?
This one's the same as that, it's just prettier.
So it's a nicer one.
And it's made out of metal, but it has the same scales. This one's the regular 1 inch equals 1 inch, but then it has all the same different sizes. This one is a engineer scale, so it's like 1 to 50, so it's meant for roads and much bigger, like maps. This is an architectural scale, this is an engineer scale.
Okay, so you've got an engineer scale, an architect scale, and are there other ones also that you guys need to?
I think
No,
that's
that's
it.
pretty much it.
Yeah.
Okay.
There's
These
just different
other,
versions of them.
these are just other different ways that we use, like this can be cumbersome to carry around to a meeting, but this you can fit it in your pocket. You know, these little paper ones, you can fit them in your notebook, and then you always have one. When we go to a meeting, we always try to keep a scale handy. So these little flat ones here are really nice because they
Yeah, I
don't
was
have
gonna
as many
say.
scales, but it only has 2, 4, 6, it only has 8 where this has 11.
Right, but I'm saying because for students, because we've got some of these in our classroom also when we do our architecture unit, and having the students use these, this is pretty handy, even though you're like, well, it's only got 8. Well, that's
Right.
quite a few to have.
Yeah.
Exactly.
Okay, so some of these other ones are pretty cool also, and I know that some students would see these and go, oh, well, I can just start drawing designs and messing around, but they actually have specific purposes for you guys.
Yeah, we brought these really kind of, this is probably what you said your uncle, who was much older back in '66, used. This is to make any size circle so that your circles are perfect and not just sketching a circle. This one is triangles to draw lines. This is an adjustable triangle that you can get any angle that you want. Some of these are plumbing fixtures like toilets and bathtubs. We don't really use any of these tools anymore because we're doing everything in the computer. The scales we still use because when we print drawings, we need to take those out. But these are kind of fun, old school tools that we still like to share. I did have some stuff on the
Yeah,
iPad
quickly
that
show
I
us
wanted
on your
to see.
iPad, because this is pretty fascinating also, so the kids can see it in 3D also.
Right. So this is a building floor plan, and I'm showing you a dimension plan, and so you can see here all these dimensions are set up per those scales that we just talked about. This one you see here in the corner, it's 1/8 inch equals 1 foot. So that's how we've scaled it down here. This is we do all our work in 3D in the computer, so we're constantly modeling is what we call it. We're building our building this is kind of a neat little tool that our software has, that this is a 3-story building, and we can look at this 3-story building in a lot of different ways, but I can then look at it in 3D. This is Bakersfield College, and you can see the courtyard and meeting spaces up at the top. It's just a nice little tool to be able to take to our clients because they can't all understand these drawings. And then I was going to show another really neat thing about this. Is you can actually measure on here. Sorry about that. So again, instead of using one of those scales, when I'm in the computer, I can actually measure this, say that column, and I'm trying to get a measurement to this column. It's 29 feet 8 inches in this scale, at 8
So
inch
that's
scale.
awfully handy right there to be
Yeah.
able to do that, right? Just being able to do that on the iPad. And then obviously, being an architect, you need to know all about that, but also there are people that need to develop that software.
Correct.
And that, I think, is a big trend for students to be able to develop software in a bunch of different fields, but having that architectural knowledge is something that you would need also to develop that software.
Correct. Yeah, you have to understand how buildings come together, but also how architects think and how we present our work. You know, we're cutting a building here in section, and so trying to understand how these buildings come together really help you see the building in any section that I'm looking at here.
So you can slice it any way you want, take a look
Yeah.
at whatever you need to specifically.
Yep.
And that is a cool little toy right there. Not even a toy, that's a tool. That's one of the tools of mathematics for architects. Well, Jeannie and Manuel from Ordiz-Melby Architects, and I understand that educational architecture is your specialty.
Yes.
And we certainly do love the schools because Highgate, where Luke is from, is one of the new schools, and you guys had part in that.
No.
No.
Highgate was not one
Oh,
of
I was
ours.
going out on a limb right there, going, all right.
We did
But I know
quite a
you
bit
guys-
for Panama Buena Vista.
Right, I was going to
but
say,
we did
because
not do
Panama,
that, yeah.
because Reagan and Williams,
We did
schools
those
like that, you
schools,
guys
yeah.
have done.
Yeah.
Okay, so I'm not totally off base with
Well,
you.
it's kind of hard to tell because Ordiz-Melby Architects has done maybe 77% of the schools, the new schools in Kern County.
What are you working on right now?
Currently,
I'm sure there's more than one thing, but
Currently, we have modernization for Fairview Elementary at Greenfield. We just finished a brand new elementary school for Greenfield School District. It's Crescent Elementary School. And we have,
I'm doing a modernization for Richardson Child Development Center, which is a KCSOS project.
so if a school district comes to you and says, listen, we want a new school, how long does it take for you to go from, all right, this is the day they told us, and then here are the plans, go build it?
we get that question a lot. We tell districts it's about a 4-year process from when they decide to need a new school to when the doors open and students are in the schools.
So it's a lot of forethought that has to go into
Yes.
this, and where you're going to put it,
Yes.
and things like that.
And it's a lot of on the districts that they have to plan out what this school is going to be like, what do they want in it, so
How
that
many
we can then
classrooms?
take that and design something to their needs.
All right, well, you know what? For coming in and helping us out with the tools of mathematics, we have a little tool for you to use at
Thank
your
you.
office, so that is just a little something
Yeah.
to say thank you for coming in and
Thank
helping
you.
us out. So anyway, once again, Jeannie and Manuel from Ordiz-Melby, and that is today's Tools of Mathematics. Now, you guys like art?
Yes.
Well, we're going to check out some of the art from Frazier Mountain right now.
One of the things I've had to tell myself is right now it doesn't look that good, but at first it never looks good. But if I just keep going and working on it, then it gets better.
It's a little different to me because I usually work with pencil, so it's a little more difficult for me, but I'm enjoying it so far. I like it.
once you let the wheel do its thing and then you're just doing your thing alongside with it, it will work. Pottery didn't work for me at first because I was trying so hard to like work against the wheel.
I always tell the students, you know, if there's a mistake to be made in life or in art, I've probably made it. And just adding slip to that isn't actually going to seal those cracks. We have to kind of knit it together by making score marks this way. If you follow these techniques and follow these processes, you will probably not fail in the same way I did. And they'll just say, I'm going to try something different. And I'll say, okay, that's fine. See how it goes for you, explore it. You know, you might find the new way to do something. A lot of times innovation comes from trying something differently. I've seen you kind of struggling with getting these angles right and everything. And I guess my question is, why? Like, if that's not what you love doing, and maybe it is, maybe that's something you want to accomplish, but if it's not, maybe let's throw that out the window and explore more the areas that excite you. Experimentation and failure are a huge part of the creative process. And if you're not willing to fail, you're really not going to do anything new or exciting. And so, you know, I try to model that, and sometimes during a demo things will fall apart in my hands and I'll be like, you know, we'll teach from there.
When I first started throwing, it was very thick and clunky and like just sloppy, and he taught me like you can do it right and it'll look so much better. He's very good at helping me realize my own ability. Like, you all gotta start somewhere, and like I would just like do what I could, and then one day I could do what I saw other people doing, you know? Like, it's just nice to be able to come in here and like hang out for a little bit. Like, it feels more like a break than a class. Feels like I'm cheating sometimes. I'm gonna probably make this a planter.
I know I had a really negative experience in 7th grade art. We did calligraphy for a really long time, and I failed that section and literally never wanted to make art again. That teacher was probably doing a section, and I just felt really discouraged by it, and I just needed someone to come alongside me and help me through it. But I never want my students to feel that way. I never want someone to give up on art because they didn't like something. I try to say that a lot during my teaching. If this isn't your thing, maybe the next thing we do will be your thing, because not everybody likes everything we're going to do.
He takes the ones that are hesitant to really realizing the progress that they can make and the love that they have for it, and the befores and after are incredible. And so when students start seeing what abilities they really have, they start opening up more and more to it, and then we have students who never thought they could be creative in their life graduating with 2 AP classes under their belt, and some even changing their minds and going into different art fields after high school.
Honestly, my career has just kind of exploded. I started at International Easy Up. It's a canopy company, so I'm doing their digital marketing. And then I'm contracted with this national beverage brand and get to do all their print and digital marketing and web design, and that's been a blast. He pushed me to see light in a whole different way, pushed me to see line work instead of objects. He also really touched on a lot of art history, which I think goes overlooked, but it explains the reasons why things were done a certain way and how they were done. And so all of that was super foundational to my art career.
You can make and sell your work, and as you guys are moving into AP and moving into what you want to do next, making and selling your own work is definitely something you can start doing. I want them to see that I'm excited about making things too, and that I'm a creator alongside of them. And if I sell a piece of art or finish something, I'll share it with them, and so that they can see he's excited about art. This, because excitement is contagious, and I really am excited. I don't have to make it up. I mean, look at these animals. They're terrible. I love this one too. It's so out of proportion. if you keep that positivity and you keep pushing forward and have that vision of end product and what I've seen in the past with students' lives being changed through art, whether it becomes their career path or just something that inspires them or that they can relate to, I think that's where the success lies.
And once again, another great segment on career pathways in Kern. 636-4357 is that phone number. Luke, a 5th grade student from Highgate Elementary, is in studio with us today. And you guys are Huskies, correct?
Yes.
All right. And once again, shirt helping me out right there. So is that your band shirt?
No.
Because I know like when you're in band in chorus, or is that just a Highgate shirt?
It's something I can wear to band, but it's just a Highgate shirt.
Oh, so it's just a Highgate shirt. I like that shirt. That's pretty sweet. It's almost like the New York Yankee blue on there right there. You like that?
Yeah.
Okay. All right, so you've been doing volume. And I've got a different problem for you to work on. So head over to the board. You and Cindy can write down any information that I say, because this is not going to be part of your little packet you brought in. All right? So it says a rectangular prism has a volume of 144 cubic units. So the volume is 144 cubic units. The base is 48 square units. What could the dimensions be? So you guys talk about that. Let me know when you come up with an answer.
What do you think?
Well, I noticed that instead of a 3, it's a 2 on the base.
Okay. So what does that tell you about, like, we know that units cubed represents a volume and a 3-dimensional figure. So what does squared usually represent?
Squared, like just a square maybe?
Okay, we can think of it kind of like that, yeah. It's sort of looks like a 2-dimensional.
Yeah,
Do you know what 2-dimensional is?
Yeah,
like flat, right?
Mhm.
So what's this tell us then? If the base, well, what shape would the base be if we have a rectangular prism?
The base, if we have a rectangular prism,
I mean, will it be a triangle?
well, it would be a rectangle.
Yeah, because it's like a rectangular prism, right? So we know we have a rectangle. That's not a very good one. But okay, and we know that it's 48 squared units.
Yeah, squared.
Does that mean 48 like that? Like, what would a squared unit look like? You said it earlier when I asked you what squared means.
Oh, 2-dimensional? Like,
yeah, and you
like
said it like a square,
a
right?
square.
So it's like when you're filling this up with squares
Uh-huh.
instead of cubes, which is 3-dimensional.
Yeah.
So it's kind of like it takes 48 squares to cover the bottom.
Mhm.
And we want to try to figure out, you know, what the dimensions are. So if we know this is the bottom and we know the whole thing equals 144,
And the base is 48.
let's say we knew numbers here, whatever they were, okay? What do we do with them to find the area of that?
Times?
Okay, so that's kind of what this tells us, the area, because squared is for area.
Yeah.
So the area of the bottom is 48. Yeah? So we know the area of the bottom is 48, but we want to make the whole thing equal 144.
So if we're timesing,
Okay, so let me ask you this. Do you remember earlier when you were talking about how when you knew all 3 parts of the rectangular prism, you knew what to do with them?
yeah.
What did you do with them?
Well, I just saw that there were 3 cubed. Like with the rectangular prism, I saw there were 3, so like length, width, and height.
Okay, and you just multiplied them all, right?
Uh-huh.
Okay, so we know that whenever we multiply the length and the width with the height, it's going to equal that.
Yeah.
All right? So what are you thinking here? What do you think the 48 would represent? Like in this formula?
The height.
Think it's the height? So if we drew one, like, let's say we drew one of these into a, okay, right?
Okay, yeah.
And then we have length, width, height. Okay. Where's the 48 at? Like, what does it represent? What part of the rectangle?
So like length with height, one of those.
Or just what part of this? Like, if this was a box, what part does it represent?
Top.
Okay, so maybe this right here?
Yeah.
Okay, we could say that. So how do you get 48 from this? What do you do with these two numbers?
You have to find numbers that you can multiply in order to get 48.
Okay, so we know that these two numbers, whatever they are, has to equal that value.
Yeah.
Yes?
Yes.
So we know that if we multiply that by something else that we don't know,
It would give us 144.
that it would equal 144. So how could we figure out what this is, first of all?
Well,
What do you think we could do with these? This kind of goes back to that algebra problem you were doing earlier.
we could find out what the length and the width is first.
Well, okay, we can. What are the possible things that can make 44?
48.
I mean 48, my mistake.
12 and 4.
Okay, so we could have 12 and 4. You know, you can write too. Go ahead, grab a
So
pen.
just leave that first one. We're just going to go 12 by 4.
Okay, so let's
So
say.
we need a 12 by 4 by something
Yeah, what's the other
to get to
number?
144. So we have 48, so it's going to be basically 48 times what will get us to 144?
48.
What could we do with these two numbers to get that number?
We could divide.
Okay. And you said you like long division, yeah?
Yeah.
All right, so let's divide those. Go ahead.
So 48 and 144.
All right.
So 48 can't go into 1 or 14. So, but it can go into 144 3 times. It can go into 144 3 times. 48 times 3 is 144.
All right, it worked out perfectly.
Yep.
So what is your third measurement?
Our third measurement is 3. Height is 3.
So it'd be, yeah. So there's one set of possible dimensions. Yeah.
Good, so we're going to leave it at that. So the dimensions could be 12 by 4 by 3. Does that make
Yes.
sense?
Yes.
All right, good. So come on over here real quick. So I've got a question for you, and I'm going to give you about 15 seconds to solve this. All right? So how long have you been doing Rubik's Cubes?
I've been doing Rubik's Cubes for...
Go ahead, talk to me and solve it at the same time. We're on
I've
crunch
been-
time now.
I've been doing Rubik's Cubes for
A year?
about like
What do you like about them?
well
I
I
know
like
I'm making you
how-
do two things at the same time here real quick. You keep working. I've got two other questions for you. Did you learn a little something today?
Yes.
Did you have fun today?
Yes.
Good. So here's what I want you to do. Look at the camera right there real quick. All right. Salute. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.